All right, on the AP exam for number 3, I gave you a big video on that, explained how to do it. And I want to go over some of the others, and I don't know what's easiest right now, so I'm just going to go over the answers. And if later you want to see something more worked out, then let's do so. Okay, so on the first question, it says, how many lone pairs does each electron, or how many lone pairs of electrons each sulfur have? The answer to that question is number 2. The next one was asking for bond. Let me hold this up. You can pause it if you need to, get a good picture of it. And that way maybe we can go on. Okay, number 2 says, what is the bond angle? I don't know if you remember much from bond angles, but typically in any bond angle that is a tetrahedral, or it would be 109.5 degrees. On like ammonia, you'll get down to 107.5. On water, because of those two lone pair really kind of shoving things together, you get down by 104.5. But this would be 109.5. They accept anywhere from 104 to 110. So that was pretty good. On C, the electron configuration, the ground state, 1s2, 2s2, 2p6, 3s2, 3p4. On D, part 1, sorry, turn the page here. It says, identify the orbital and explain the difference between binding energies. Well, X is 1s. So that represents an electron. So chlorine has a greater positive charge than with sulfur. So there's more energy and attractive force. And so it says, why is that binding energy going to be a little bit different there? And for number 2, it says, where would you put this peak? Well, I would put the peak to the right of Y, because that means lower energy, and a little lower than Y, showing fewer electrons. And you kind of see that peak right over there. That's where I would place it. Okay, on part E, it says, where am I at here? Use a data table to determine the order of the reaction. Well, I said that sulfur concentration increased by a factor of 3. The concentration of hydroxide was held constant, and the rate also increased by a factor of 3. So that makes it first order. In part 2 of that, it's also first order. You doubled the rate with S8 being held constant and hydroxide doubled, and so therefore you have that first order. And then last question says, use particle level reasoning for 2 explanations to account for the fact the reaction rate is slower than trial 2. I said, well, lower temperature means lower kinetic energy of the particles, which means fewer collisions and thus fewer reacted. Also, the energy of each collision would be lower, and therefore resulting in fewer molecules having the activation energy needed to react. They really get big on throwing some of those terms around, and so kinetic energy is a good term, orientation is a good term, activation energy, all those are good terms, and so that'd be good. And I lied to you, this was problem 1. All right, now for problem 2, I'm going to go ahead and do both of those on this same video. On problem 2, it says you have an equation there, and it says the student claims that the redox reaction is correct. I was very proud of you. All you said no. The oxidation numbers don't change, so therefore it's not a redox reaction. On number 2, it asks you to find how many grams are needed to react with 3 grams of hydrochloric acid. And I don't know if you can see that or not. Most did that and get 4.81 grams. Okay, on part B, it says, does the total pressure of the vessel increase, decrease? Total pressure must remain equal because you have 2 moles of gas on the left, 2 moles of gas on the right. Therefore, the pressure must stay the same. So that was a good problem on that one. Question 2, what's the next one asking here? In terms of intermolecular forces, no, I missed that part, didn't I? Explain why the boiling point. Okay, I've got a missing section here, so I apologize on that. I found Kp was 4.7 times 10 to the negative third, or to positive 3, so it's very large. So the reaction rate will run to the limit we're going to use up. In this case, the methanol. So I said methanol's concentration is 0. Methanol chloride and water would both be 0.25, and hydrochloric would be 0.6 minus 0.25 or 0.35 atmospheres. And then the question for part 3 of that, I said, I agree the system's equilibrium, so some methanol must still exist. For the reaction, I said London dispersion forces and dipole-dipole forces. And then also I said ammonium, good grief. The methyl bromide is a larger molecule, so London dispersion forces would be a little bit greater on that. And then I think I'm back to my problems there, so I just given the answers. On D part 1, I don't have that one either. It says what would be the pressure, and you calculate the pressure, and I use PV equals nRT. And let that focus for a second. And I get 242 atmospheres, and that's very large. That's when it's allowed to warm up. It's probably going to rupture that glass and just make it explode. And so that's why it would be a bad idea to have that anywhere around. Okay, so that brings us up to problem 3, which I've already done a video on that. And so I'll go ahead and stop at this point. So there's questions 1 and 2, and then I'll do 4, 5, 6, and 7 on a different video.